So this is section 2.4, deductive reasoning. When we finish, I want us to be able to use the law of detachment and the law of syllogism. So let's begin with the definition of deductive reasoning. Deductive reasoning is a process of reasoning logically from given facts to a conclusion. So let's begin with the law of detachment. The law of detachment is, if the hypothesis of a true conditional is true, then the conclusion is true. And it'll make more sense in a second. So if P, then Q is true, and P is true by another statement, then Q is true. So let's take a look at that over here. So we're given if a student gets an A on the final exam, then the student will pass the course. Felicia got an A on her history final. So my hypothesis, or my p-value, is a student gets an A on a final exam. Then my Q, or my conclusion, is the student will pass the course. So if Felicia got an A on her history final, I can conclude that Felicia will pass the course. So let's look at this again. So we have if P, then Q, and if the hypothesis is true, then Q is true. So my hypothesis, or my p-value, is if a student gets an A on the final exam, then the student will pass the course. And they tell me that Felicia got an A on her history final exam. So this is the statement that is true of the hypothesis. So I can conclude that the Q will happen, that Felicia will pass the course. Now let's take a look at another example. So we're given if a ray divides an angle into two congruent angles, then the ray is an angle bisector. And then the statement is ray RS divides angle ARB so that angle ARS is congruent to angle SRB. So that's a lot to unpack. So let's start with identifying our hypothesis. So we have a ray divides an angle into two congruent angles. And next, what is our conclusion? The ray is an angle bisector. So now let's look at our statement. We have ray RS divides angle ARB so that angle ARS is congruent to angle SRB. So a ray divides an angle into two congruent angles. So that is what this says. So we can conclude that ray RS is an angle bisector. And I use the symbol for angle instead of writing out the word angle. So let's take a look at another example. So I'm given if two angles are adjacent, then they share a common vertex. And then my statement is angle 1 and angle 2 share a common vertex. So notice, okay, first let's highlight our hypothesis. Two angles are adjacent, and my conclusion, they share a common vertex. Now notice in these other examples, my hypothesis and my statement were the same, or they were both, they made they were true of the hypothesis. So this one does something a little different. This one tells me angle 1 and angle 2 share a common vertex. That gives me my conclusion. It doesn't do anything with the hypothesis. So it doesn't tell me that the angles are adjacent. So I can't draw any conclusions. The law of syllogism is going to be another way we can draw conclusions. So it states if P then Q is true, and then if Q then R is true, then if P then R is true. So let's look at the example. So if it is July, then you're on summer vacation. Notice that on the next one, the Q then R, it's got the conclusion as my hypothesis. So if you are on summer vacation, then you work at a smoothie shop. So we can now conclude that if it is July, you work at a smoothie shop. So let's take a look at this example. If a figure is a square, then the figure is a rectangle. This takes my conclusion, and in my next statement, my conclusion goes first. So then the figure, if a figure is a rectangle, then the figure has 4 sides. So I can conclude that if a figure is a square, then the figure has 4 sides, because it used the law of syllogism. And that happens when you use your conclusion, and in the next statement, it is your hypothesis. So once again, we can conclude if a figure is a square, then it has 4 sides. Now let's take a look at this example. If you do gymnastics, then you are flexible. If you do ballet, then you are flexible. So both conclusions are the same. The conclusions didn't change, so we cannot use the law of syllogism. So we cannot draw any conclusions. So on this example, we're going to use the law of syllogism and the law of detachment. So they want to know what we can conclude from the given information. If you live in Accra, then you live in Ghana. If you live in Ghana, then you live in Africa. Aisa lives in Accra. So what can we conclude? So with the law of syllogism, we can conclude if you live in Accra, then you live in Africa. So remember, the law of syllogism says we can take these two statements, because you live in Ghana is our conclusion here, and it's our hypothesis here. So we can say if you live in Accra, then you live in Africa. So that was using the law of syllogism. So now we can use this new conditional statement that we have and the law of detachment to conclude. See, it says Aisa lives in Accra. So we can now conclude using the law of detachment that Aisa lives in Africa. Now, one of the biggest challenges of this is sometimes you're just going to see it, but you're not going to be able to, you're going to have more trouble telling what the steps are than you are just knowing what the answer. And it's really important for you to be able to tell what the steps are for what we have coming up later.